फर्स्ट लेक्चर ऑफ थर्मोडायनेमिक्स। देखो नाम से क्लियर है, थर्मो मीन्स थर्मल, है ना। डायनामिक्स मीन्स मूवमेंट, है ना। तो ये जो है, जो भी केमिकल एनर्जेटिक्स बोलो या थर्मोडायनेमिक्स, इट इज ब्रांच ऑफ साइंस किससे डील करती है, विच डील्स विद द एनर्जी चेंजेस in a chemical reaction। ठीक है ना। तो केमिकल रिएक्शन में जो भी एनर्जी चेंजेस होते हैं, चाहे वो इवन अपना केमिकल रिएक्शन के अलावा भी जैसे फिजिकल प्रोसेसेस होते हैं, इवेपोरेशन है वाटर का, सॉल्ट वाटर में डिजोल्व कर दिया आपने, आइस मेल्ट हुई, तो ये भी इसमें इन्वॉल्व रहते हैं, केमिकल रिएक्शंस और इवन फिजिकल प्रोसेसेस, है ना। तो फिजिकल प्रोसेसेस में भी इवन जो मैंने अभी जो गिनवाए आपसे, है ना, तो उनमें भी जो एनर्जी चेंजेस होते हैं, है ना, फिजिकल प्रोसेसेस में भी, राइट, तो वो सारे ही ये कवर करता है, कौन, थर्मोडायनेमिक्स, है ना। समझ गए? ओके। तो थर्मोडायनेमिक्स में सबसे बड़ा जो पॉइंट है वो आता है कि सिस्टम, क्योंकि कोई भी हम कुछ करेंगे तो हम किस पे करेंगे, सिस्टम पे। सिस्टम में रिएक्शन हो रहा है, सिस्टम है क्या, सिस्टम ये। तो अकॉर्डिंग टू थर्मोडायनेमिक्स हमें डिवाइड करना पड़ता है, किसी भी मतलब बाउंड्री बनानी पड़ती है कि एक सिस्टम है और दूसरा क्या है, सराउंडिंग। हम दोनों को पहले डिफाइन करते हैं। डिफाइन किसको करना होता है, सिस्टम को, बाकी जो भी बचता है वो सराउंडिंग होता है ना। तो हम थर्मोडायनेमिक्स में मेन जो हमारा फोकस रहता है वो रहता है सिस्टम पे, कि सिस्टम पे जो होगा सराउंडिंग पे उसके अपोजिट होगा, है ना। क्योंकि सिस्टम एक ऐसी चीज है जिसको हम स्टडी कर सकते हैं, बट सराउंडिंग को वी कैन नॉट स्टडी। तो हमारा मेन जो फोकस रहता है वो किस पे रहता है, सिस्टम पे। ठीक है। तो सिस्टम जो है इट इज द स्पेसिफिक पार्ट ऑफ द यूनिवर्स। पूरे यूनिवर्स की बात हो रही है। यूनिवर्स में हमें आइडेंटिफाई करना पड़ता है कि ये जो पार्ट है, ठीक है, कौन सा पार्ट, इन विच एनर्जी चेंजेस आर टेकिंग प्लेस, एनर्जी चेंजेस तो हर जगह हो रही है, पर जिस पे हमें इंटरेस्ट है ना, वो जो है उसको हम बोलते हैं सिस्टम। ठीक है ना। अब सिस्टम छोटा भी हो सकता है, सिस्टम बड़ा भी हो सकता है। जैसे अभी हम बात करें तो हमारे लिए जो सिस्टम है वो क्या है, बोलो, हमारे लिए अभी जो है वो सिस्टम क्या है, हमारे जो आसपास जगह है, ताकि हम जो भी सुन रहे हैं, है ना, वो डिस्टर्ब ना हो। तो हमारे लिए सिस्टम क्या है, जो रूम जिसमें हम बैठे हैं अभी, है ना। तो साइज ऑफ द सिस्टम वेरी मे वेरी फ्रॉम वेरी स्मॉल टू वेरी लार्ज। जैसे हम स्कूल की बात करें, चलो, स्कूल में अगर मान लिया क्लास चल रही है, तो जो क्लास है वो क्या होगा आपके लिए? सिस्टम। उस टीचर के लिए वो क्लास क्या होगा? सिस्टम। ठीक है ना? बट प्रिंसिपल की बात करें तो प्रिंसिपल के लिए सिस्टम क्या हुआ? पूरा स्कूल, चाहे वो प्लेग्राउंड है या कोई भी क्लास है, वो सारा क्या होगा उसके लिए? सिस्टम। क्योंकि वो उस सारे को, चित्रा एस, यस आई कैन, ओके, so let's start in English. Okay, so that means for the teacher that class is the system, but for the principal whole school is the system. For chief minister state is the system, right? But for the prime minister whole country is the system, right? So it depends on the particular person. ठीक है? Means that part of the universe which is under study, which we are going to observe, right? Got it? For example, if we talk in terms of okay, in terms of country, in terms of okay, PTI. For PTI, when prayer is going on, assembly time, right? So that particular, at that particular time, that prayer is the system, okay? Or the line in which rows, okay, rows and those how the arrangement is for the whole school, that is the system for the PTI, right? So it depends on the particular person and particular system. For example, if we are in lab, then that laboratory is our system. I think you have an exact idea what do you mean by a system. Means any specific part of the universe which is under observation of a particular person, okay? Now next is surrounding. So surrounding means, surrounding, it represent the rest of the universe, right? It represent rest of the universe, okay, which surrounds the system. Now sometime what happened, we think that like if this room is our system, right, in which we are studying right now, okay, learning the watching the video, okay, so immediate next is the surrounding, but it is not true. Anything happened beyond it, even in US or Germany, that is surrounding for us, okay? Anything out of system is the surrounding. That's why we are not able to study the surrounding, okay? So to study the surrounding, we just observe the system. Like system absorbs 10 joule of heat. So that means it is absorbed from the surrounding. What it means? What surrounding did? Surrounding releases 10 joule of heat, okay? So we cannot observe surrounding, but by observing the system, we have an idea what is going on in the surrounding. That's it, okay? Because if delta H is positive for the system, the same value is negative for the surrounding. Okay, so system and surrounding. So better to go for system only. Okay, whenever there is a question of surrounding, just carry out the operation for the system and you will get the value for the surrounding. Okay, now say there is a boundary, but this boundary may be real or imaginary. The system and surrounding are separated by a real or imaginary boundary. Keep in mind. Now, types of systems. System and surrounding can exchange mass or energy with each other. Okay. So, mass and energy based on the exchange of mass as well as energy, they are classified as open system, closed system, and isolated system. Okay, these are three systems, right? In thermodynamics, there is open system, closed system, isolated system. So, simple example is like if we have a cup, ठीक है, filled with tea, okay, that is open from any side, okay, obviously above it, otherwise it will go away, it cannot be stored. So second is cup again filled with tea, but now there is a covering over it. And third one is it is closed, there is a tea in the thermos flask, but it is covered from all sides. In this case, in first case and second case, walls are diathermic. Walls are diathermic. What do you mean by diathermic? Diathermic means they can exchange energy. They can exchange energy with the surrounding. Okay. But in isolated, the walls are insulated. There are insulated walls. Walls are insulated. Okay. In first case, it is open. So tell me, they can exchange a system is said to be open if both mass means matter, okay, mass and energy means heat or work, okay, can be exchanged with the surrounding. Okay, and they can exchange, okay, energy as well as mass, okay. For example, if we have just like tea in the cup, there is an evaporation. So because of evaporation, mass is exchanged, and if it is hot, it turns cold. So heat is also exchanged. So it can lead to the exchange of mass as well as energy, and that is called open system. But in closed system, there is only exchange of energy. In closed system, there is exchange of energy with the surroundings, okay, and no exchange of mass takes place. So as no exchange of mass takes place, right, that is called closed system. Naphthalene ball, beta, if they are placed in open, you mean to say that is open system, simple, okay. Because there is in naphthalene balls, they get sublime, okay. So sublimation takes place from solid directly to gas, so they absorb some heat, right, and at the same time they go away. Now in third case, a system is said to be insulated, isolated, yes, when it is called isolated, when, yes, you have thermos flask, right. First thing, keep in mind, no system is perfectly isolated, okay, no system is perfectly isolated, but it is an ideal case when there is no exchange of mass or energy, okay. A system is said, very good Chitra, a system is said to be isolated if there is neither exchange of mass nor of energy, right. Such a system is said to be isolated, okay, obviously with the surroundings, okay. It is isolated from the surrounding, simple, okay. Like we have hot tea or even hot water in a thermos flask. Okay, it represents an isolated system. System के अंडर, yes, that means for isolated system there is no surrounding. For isolated system there is no surrounding, because it cannot be there is no interaction between the system and surrounding, so it is in its own, it is whole universe. So we can say universe is perfect example, right, for isolated system. But it is not possible to completely isolate or insulate a system, because certain amount of energy is always exchanged with the surrounding, right, even due to radiation. Okay, even you can I think you have an idea, when we pour that hot tea or coffee in thermos flask, after some time temperature of the hot coffee or tea decreases, which is kept in thermos flask after few hours. That means heat energy has been transferred to the surroundings. It means that heat energy is transferred. Next is homogeneous and heterogeneous systems. Homogeneous and heterogeneous systems. Now, homogeneous and say, so far we have discussed the types of system on the basis of mass and energy exchanges with the surrounding. Now, based upon the nature of constituents, now we will classify based on the nature of constituents. The systems are classified as homogeneous and heterogeneous. So, homogeneous, as the name suggests, homo means same. So, in homogeneous system, all the constituents present are in the same phase and the composition of the system is uniform throughout. Okay, like if we have a single pure substance in the solid state or liquid state or gaseous state, even mixture of gases, mixture of gases are homogeneous, or mixture of two miscible liquids. Can you tell me what do you mean by miscible? So, a system is said to be homogeneous if all the constituents are in the same phase. Okay, phase means, yes, phase means that they form homogeneous mixture. Okay, like liquid. Okay, so liquid is maybe alcohol or water. So alcohol when mixed with water, it remains in liquid state. So they have same phase and that is uniformly distributed. Means which can mix together. Okay, they remains in the same phase, right? And the composition of the system is uniform, and the composition of the system is uniform throughout. ठीक है. For example, any single pure substance like he said naphthalene. So naphthalene in its own sense is single pure substance, so that is called homogeneous mixture. Alcohol and water, best example, they are miscible liquids, means they are completely soluble in each other. Okay, mixture of gases, so they are all homogeneous systems. Now heterogeneous system, they are said to be heterogeneous in case it consists of two or more phases, right, and its composition is not uniform. Okay, so such a system is called heterogeneous. Very good. Oil in water. Okay, or even mixture of two or more solids, or mixture of, like oil and water means immiscible, mixture of any two or more immiscible liquids. Or insoluble solid in contact with liquid. Say phase one example, say if NaCl is in water, tell me, is it homogeneous system or heterogeneous system? NaCl in water. NaCl in water, beta, it is homogeneous system, because when NaCl is dissolved in water, you know, you cannot say NaCl, but if you write sand in water, then that is heterogeneous system. Got it? So NaCl in water is homogeneous system, sand in water is heterogeneous. Insoluble solid in contact with liquid, right? If insoluble solid is there in contact with liquid, then that is heterogeneous system. But you know, NaCl is soluble in water. Okay, as it is soluble in water, that's why it makes homogeneous system. Phase and state are different thing. Phase means any homogeneous mixture. There is only one phase. Like if you have alloy, in alloy there are two metals, two solids, but they form homogeneous mixture. NaCl is water, NaCl loses its identity. Okay. Okay, then I will stop here today. We have studied only what is system today.